This conference will now be recorded.
Welcome to R18 BTech ECE third year ECE students to subject called microprocessors and microcontrollers. So here what is the difference between microprocessors and microcontrollers? Here I am showing in diagrammatic manner. So this is the block diagram of a computer. So in this block diagram of the computer, the main parts here are two types of memory, ROM memory and RAM memory. Serial interface devices, I/O ports, timers. Here everything is a single chip. So microprocessor is one of the component in the system, whereas in the microprocessor is one of the core, and all the blocks are packed into a single chip called microcontroller. So microcontroller itself can act as a microcomputer. So whatever the functionalities can performed by computer by having different components on a motherboard, all are packed into a small chip which is called as microcontroller. So this is one of the difference between microprocessors and microcontrollers. Now when we go to shop to buy a laptop or mobile phone, the shopkeeper says mainly two or three hardware devices. What are the hardware devices? They will explain mainly and they will focus on here is. So one is a memory unit. So the memory may be RAM memory and ROM memory. And this RAM and ROM may be on-chip memory or off-chip memory. And the other one is called processor or microprocessor. Uh, because these two devices plays an important role to decide the performance of the device. And the third one is called the camera, which is an application. Being the engineers, we have to think about only processors and RAM and ROM, not the camera, because the camera is an application which will be run by the processor and RAM and ROM. So we have to think about RAM and ROM memory and processor mainly. And here I am giving an example, a Realme phone, and this phone is having 6 GB on-chip RAM and 128 GB ROM, and it has a CPU P60. So here they are giving mainly these devices along with these remaining functional units. This video shows what is a smartphone. So what are the different types of processors we are using in mobile phones, latest mobile phones, or top 5 best processors I am giving here. So Qualcomm, Snapdragon, Apple A series and M series, Intel Atom processors, NVIDIA Tegra series, and Helio X20. And there is one more by Samsung company called Exynos. Before learning the remaining, first we have to see what are the useful and applications of microprocessors and microcontrollers. Here I am giving in a diagrammatic images manner. And robotics, microcontrollers and microcontrollers will be used in robotics, automobile engineering, home automation, and biomedical applications we are using. So microprocessor applications. So when this microprocessor was invented in 1970 onwards, people's life has become very easier because of its low cost, low power, small weight, and uh, reliable, more reliable. It is using in the all fields of engineering nowadays. And here I am giving some of the applications. So, for example, it is microprocessors and microcontrollers will be used in household devices, industrial applications, transportation industry, computers and electronics, microcomputers and supercomputers, in medical applications, instrumentation, entertainment, embedded systems, office automation, communications, and so on. So these are the in detailed applications of household devices, industrial application, transportation industry, computer field, medical field, and instrumentation. For example, if we take instrumentation field, and it is using for function, designing of function generators, frequency counters, frequency lasers, spectrum analyzers, and so on. Like that, every individual application is having its detailed applicative different applications, and microcontrollers are also used in different same applications. Suppose if you take medical applications, uh, they are using in ECG machines, IQ check, sugar level testers, and so on. Communications, they are using cell phones, telephone sets, answering machines, automatic answering session machines, and so on. And we are using the word buzzword called smart everywhere. So, what is the meaning of smart TV, smart TV, smart watch, smart home, smart energy meters? Smart means here a smartphone contains several components, including processors. It incorporates the functionalities of a handheld computer to run different user applications. So this is the difference between smartphone and the normal phone. It is used to run different user applications because it acts like a handheld computer. And one more application, smart meter. A smart meter is an electronic device use microcontroller and that records information such as consumption of electric energy, voltage levels, current and power factors, and so on. So this is setup box internal diagram, and the setup box is having one microcontroller, and this is the block diagram of smart metering. In this smart metering also we are using one of the main part of the smart metering energy metering is microcontroller, and this is the difference between conventional energy meter and smart meter system. So in the conventional energy meter, we are collecting the data manually and we are giving bill. Billing also manually does. Whereas in smart meter system, we are using microcontroller and so it is automated. And the data also stored in the database system. And this is IoT based smart home security system with alert and door access. And in this system also we are using one ARM 776J, which is called as ARM processor. And this is IoT application. So this is the block diagram of the digital computer today, which we are using mostly on desktops and laptops. And this computer is having input devices, output devices, and the microprocessor unit. And this microprocessor unit comprises of three main sections. One is control unit, and second one is called arithmetic and logic unit, which is also called ALU unit, and register set. So by comprising of these three units only, they are manufacturing the microprocessors, and it one of the one more main component of digital computers is primary storage and secondary storage. And here, what are the input devices? There are different types of input devices: keyboard, image scanner, microphone, pointer device, joysticks, and all. These are all called as the input devices, and these are all called output devices. And here, these are the primary storage: RAM memory and ROM memory. RAM memory for temporary storage and ROM memory for permanent storage. And secondary storage, these are secondary storage: hard disk, floppy disk drive, DVD disk, pen drives, magnetic and tapes, and all are called as secondary storage. And all the secondary storage devices are permanent storage devices. And these are the communication devices, different communication devices to connect with the external world. And this is the block diagram of the computer. Here I am showing once again. And this part, mainly this part is called as, generally we call it as CPU. But is this really called as CPU? No, generally this is called as CPU bonnet. And this CPU bonnet internally having motherboard, and this is the interconnection of computer components. See how RAM, IO interfaces, and all are connected through to CPU to perform many tasks through this address bus, data bus, and control bus. These three buses called as system bus. So, so this is the motherboard front panel. So this motherboard is having a ROM, PCI slots, backup battery or CMOS battery, and different connecting units like USB, PS2 cable, mouse connector, and RS-232 cable, and so on. And this is the place which we are going to discuss now from today onwards, which is called as CPU socket. Uh, and these are the CPU heat sinks. Heat sinks are really required because when we are when we send some data, that will be always processed through a microprocessor. Means most of the work is done by the microprocessor, so we need a cooling system. So heat sinks will provide the required cooling here. Means more amount of heat will be sink in this heat sinks. Uh, this the processor is also called as brain of the computer. So these are some of the input and output devices. And my name is B. Srinivasrao. Today onwards, I am going to explain the microprocessor and microcontroller circuit, and in short, it is called as MPMC. So, a microprocessor is also called a CPU. So, all the engineering students today onwards, we have to say that CPU means only the microprocessor, because the CPU stands for Central Processing Unit. So, when we perform any operation, the CPU or the central processing unit only will perform. That's why it is called as a central processing unit or microprocessing unit. So the CPU is like the brain of the computer. It tells the other parts what to do, like our human brain. So our human brain also will take care of all the organs of our body, what kind of functional to be performed, when it to be performed. Otherwise, when we are sleeping also, our nose will take breathing. How it will perform? It will perform by the brain of our human body. So that is the importance of this microprocessor. It acts like a brain of the computer. So why it is so popular? Because of so many reasons. They are called as features of microprocessor. And here these are the features of microprocessor: low cost, low power, small weight, and more reliable, and small in and low versatility. And these are the different types of microprocessor features. And what is a microprocessor? Microprocessor is an integrated circuit, or it is also called chip, that contains all the functions of a CPU on a computer. So it is normally performs the many functions such as word processing, calculations, and communications via internet or telephone. And microprocessor is also called as MUP. Mu is pronounced as uh, mu because we are performing the operations in terms of microseconds. So that's why it's called as microprocessor. Its clock frequency is in terms of megahertz. So what is the meaning of 64-bit microprocessor or 32-bit microprocessor or 16-bit microprocessor is because as we have seen in the system bus, the previous slides, here the width of the data bus must be 64-bit, and the size of the register set must be 64-bit, and size of the ALU to perform arithmetic and logical operations. This is the main unit in microprocessor to perform the various operations, and its size also must be in terms of 64-bit. This is the difference between microprocessor and microcontroller. I was discussed already. So these are the textbooks and references, different textbooks. So the first one is a very popular textbook, Advanced Microprocessors and Peripherals by A.K. Ray. And the second unit, 8051 Microcontrollers by J. Ayala. And fourth and fifth unit by ARM System Developer by N. Sloss. These are different textbooks. And here, these are the course objectives and course outcomes. Any course will have some objectives and outcomes. So to help the students to understand why we require this course, so they are called as course objectives. So to familiarize the architecture of processors and controllers, to provide the knowledge about interfacing techniques of bus and memory, course outcomes. Upon completing the course, the student will be able to understand the internal architecture, organization, and assembly language programming of 8086 and 8051 controllers and ARM processors, and prerequisites for my MPMC subject. So, what are the requisites to learn this MPMC subject is switching theory and logic design subject. Sometimes it is also called digital electronics. In that subject, we have to learn about binary and hexadecimal number systems, integrated circuits, and its application subject. In that subject, we have to learn about what is an IC types of ICs and their pin diagrams. Means how to pack this chip into how to pack this complete circuit into a single chip, which is called as pin diagram. Second one, programming knowledge. In that programming knowledge, we should learn about syntax and mathematical knowledge on basic arithmetic like addition, subtraction, multiplication, division, sorting, and all. In terms of hexadecimal number system, because microprocessors understood hexadecimal number system. So this video shows input converts physical input to binary information, And here at the output side, again this binary information will be converted into physical output. So here this binary means basics of digital. So here onwards we are going to discuss how data is represented in binary, hexadecimal, and how this binary can be represented again in terms of nibble, byte, word, and how to represent in terms of hexadecimal, what are the advantages, disadvantages, and applications of hexadecimal number system and so on. Number system. So number system can be represented with any base, but here we are representing or we are going to see three types of number systems. If it is base 10 decimal number system, base 2 binary number system, base 16 hexadecimal number system. This subject already studied in second year or previous years. That's why I'm not focusing on in detail explanation of these number systems. So base 10 means so we will have 10 values. They are 0 to 9. Binary means there are two values with base 2. They are 0 and 1. Hexadecimal means base 16. We are having 0 to 15. So we will see hexadecimal number system data in the coming slides. And the data representation in terms of bit, nibble, byte, word, and long word, and so on. Here I am having one question. How data, suppose for example, audio, songs, or images or pictures, they are stored in your computer. When you play the song, is it like that? It is stored or it will play as it is? No. What is happening? See, it is stored in terms of millions and millions digital data in terms of zeros and ones. Because you know that why it is representing with millions, because one song equal to 4 MB, 5 MB, here 1 MB. M stands for million. Suppose when we shot an image through a camera, how it is storing in terms of zeros and ones, so that we will see here. Uh, what is the meaning of 48 megapixel camera in your phone? Because when megapixel is more, why image is so clear? Because because when we are shooting some image, that image is through the camera lenses, and this lenses screen is composed in terms of rows and columns. These rows and columns are called pixels. So the pixel is the short form of picture element. A pixel is a single point in a graphic image. Graphics monitors displays pictures by dividing the display screen into thousands or millions of pictures around in rows and columns. That's why here, if you see this, these are all called pixels, and here P8 is placed in this place. So when an image is placed in the so and so point, according to the convenience of the designer, they will take it as either 0 or either 1, because digital functions can be represented with SOP functions and POS functions. Usually we will take SOP function. So when it is placed in that uh, pixel point, it will be termed as logic 1 or binary 1. So here you can see that 12 megapixels shot and 48 megapixels shot. So image is so clear if it is more megapixels. That's why this mobile phone companies also they are exposing this term in terms of camera, more megapixel, 12 megapixel, 16 megapixel, and 48 megapixel cameras. Because if it is more and more megapixel, image is also more and more clear. So here I am giving a true color or single color. Why it is called a single color and true color? Because I am representing with black and white. So that's why I am taking it as a single color. Sometimes we represent with the black and white as two colors also. So that's why I'm showing it as two colors. Pixel image. See here at this point, we're having a two black color points. That's why here they are represented two ones. And here also it is covered with two boxes with black color, and it is termed as logic 1 and logic 1. And whenever there is no black in this color, they are treating it as logic 0 only. See here, this horizontal uh, boxes 1, 2, 3, 4 are covered with the black color. So that's why they are taking 4 ones here. So this is called binary representation of your image. So here we are having one more example of J. Right, whenever it is covered in the box, it is taken as logic 1. So in this way, the image is converted into binary values. It is called single bit double color image representation. And here we are taking more than two colors. Suppose I am having four colors, and these four colors are represented with the two bits. That's why if it is yellow, so they are taking it as 1 0. Here you can see that. So if it is white color, it is represented as 0 0. If it is black color, it is represented as 0 1. And if it is a blue color, it is represented as 1 1. So like that, we can represent any bit combinations depending upon the number of colors. So usually we will take 256 color images. So those images will be presented with 8 bits, which is also called as 1 byte. So what are the applications on advantages and disadvantages of hexadecimal number systems? So these are the applications of hexadecimal number system. So hexadecimal number system is commonly used in computer programming and microprocessors, and it is also used in used to describe colors on web pages, and it is used to represent two hexadecimal digits for millions of possible colors. Hexadecimal number system is used to describe locations in memory for every byte, and it is also very easier to read and write than binary number systems. Advantages. Uh, Hexadecimal number systems used to represent 256 values with two-digit representations. The two-digit representations are 00H to FFH. Whereas in terms of decimal numbers, the two-digit representations are only 100 values, that is 0 to 99 or 1 to 100. So this is one of the advantage. More number representations are there, and we are also used to represent memory addresses. And one more advantage of this hexadecimal number system is it is used to handle input and output in the hexadecimal form, and wide number of advantages in data science field, artificial intelligence, and machine learning field. And one of the main drawback or disadvantage is it is very difficult to perform the multiplication and divisions very easily. That is the main drawback or disadvantage of this one. And here how to represent the data in terms of bits, nibbles, and bytes. So as I have given this table, if the bit length is 1, it is called as bit. If bit length is 4 bits, then it is called as nibble. Here I am giving an example also. 1011. If the bit length is 8, it is called as byte. 10110101. So 8 bits, that is called as 1 byte. So on CD-ROMs also they are used to write one CD-ROM capacity is 700 capital M capital B. Here capital B indicates megabytes. Means one basic CD-ROM can store up to 700 megabytes of data. Why they are representing with the megabytes somewhere? So many reasons are there, because ASCII code is also in terms of 8-bit or bytes representation. Now one more name is there, word. Word is another length buzzword that gets thrown out from time to time. Word is much less image sounding and much more ambiguous because We are all today using more than 8-bit representations are in terms of word only 16-bit, 32-bit, 64 and so on. Or 8086 microprocessor is 16-bit microprocessor and ARM processors are 32-bit and 64 processors. Here I am giving a little bit about hexadecimal number systems. I am not going to explain in detail like digital electronic subject. So hexadecimal number systems are numbers represented with the base 16. So base 16 means we will have 16 values. So they are represented with the 0 to 15. And whereas after 9 here we will call 10, 11, 12 to 15 with characters A to F. So that I am going to show in the next slide. So here these are the decimal number system, and these are decimal values 0 to 15, and these are the hexadecimal number systems. Here H stands for hexadecimal. So after 9, here we are having 1 0 10, 1 1 11, 1 2 12, 1 3 13, 1 4 14, and 1 5 15. But here for the place of 1 0, here we are taking this as A and 11B, 12C, 13D, 14E, and 15F. If it is 16, here it will represent as 10H. 10H. So, and here how it is equal. So, here we have to take like this in terms of binary 2 power 0, 2 power 1, 2 power 2, and 2 power 3. So, this is also one type of representation of hexadecimal. And they will also suppose convert 1 byte binary to hexadecimal. Solution is how to convert hexadecimal from binary. Consider 4 bits from right side and then represent with its equivalent hexadecimal value. So in this example 11100011. So 0011 is an equivalent of 3 and 11110 is an equivalent of B. Because it is 14 and it is 3, so it is represented as E3H. So here I am giving E3 base 16. So different examples of hex and binary. So 1 base H equal to 0001, 2 3 H is equal to 0010 because this is equal to 2 and these 4 bits are equal to 3 because in hexadecimal we are representing each decimal value with its equivalent of 4 bits. So here I am giving one more example in detail. 134AH. Why I am giving different colors is here it is equal to 2 bytes. See, 1 is equal to 4 bits, 3 is equal to 4 bits, 4 is equal to 4 bits, and A is equal to 4 bits. So total 16 bits. So I am dividing into 2 bytes of data. So 2 byte equal to 16 bit. That's why I'm giving two different colors. So 1H means 0001, 3H means 0011, 4H means 00 base B, and AH means 1010. So this is a representation between binary and hexadecimal number system. So here I'm giving some of the examples, and this data usually they are representing in terms of 2 power values. So 2 power 16 is equal to 64 KB, 2 power 12 equal to 4 KB, 2 power 10 equal to 1 KB, 2 power 20 equal to 1 MB, 2 power 30 is equal to 1 tera. So 1 kilobyte, 1 megabyte, and 1 terabyte. So here we should have some knowledge on signed and unsigned operations, carry and auxiliary carry, and a parity bit. So here binary representations. Data can be represented in terms of unsigned representation and signed representation. In unsigned representation, the data values are positive values and positive numbers only from 0 onwards. Whereas in signed operations, we can have both positive values as well as negative numbers. And this positive and negative numbers will be represented in three formats: sign and magnitude form, ones complement form, and twos complement form. So generally we use twos complement form for our applications. And this is the data representation in three different formats. Usually, sign representation will be used in negative subtraction applications. So auxiliary carry means here when we are adding say data, if there is a carry from nibble to nibble. Nibble to nibble means here a group of 4 bits is called as a nibble, right? So when the first nibble addition is generating one carry, and if it is goes to next level, then that carry is called as auxiliary carry. We'll discuss this in the flag register. And parity is an extra bit to verify the number of ones either even or odd, and this parity bit mainly used for communication devices to check the error. This is sender and this is the receiver, and here this is the data, and for this data we will add one parity bit. This is called parity bit and this is called data. So here when if weight is becoming 1, so now count number of ones 1, 2, 3, 4. It means data is converted into even parity. If it is 0, then 1, 2, 3, 3 ones are there, then it is called as odd parity and it will be transmitted to receiver section. And here this parity will be relieved by using some relieving techniques, and then the data will be accepted if it is no error. So these are the some of the practice questions: how to convert binary number and hexadecimal, and convert binary number to hexadecimal. We will discuss these practice questions in our discussion time. And this is the procedure how to convert binary to hexadecimal number system. So divide the binary digits into groups of 4, 4, then it gives the equivalent hexadecimal. So hexadecimal addition, how to perform the hexadecimal addition? Suppose I want to add 36 with 42. Then add 6 with 2. So 6 with 2 is 8. 3 plus 4 is 7. So the value is not greater than 15. So it is 78H. 28H and 45H. So add 8 plus 5 is 13. So 13 equivalent is D in hexadecimal. 2 plus 4 is 6. And third one, 28 with 58, add 8 and 8. How much? 16. So divide, if the value is greater than 15, divide with 16. Then the remainder will be placed here and placed here. So if you divide 16 by 16, remainder is 0 and coefficient goes to here, because 1 0 is an example of is an equivalent of 16 in hexadecimal. That's why here we're writing 1 0. The next one is 2 plus 1 3 and 3 plus 5 is 8. The next example is 6a and 4b. 6a and 4b. A plus b is equivalent of 21. So divide this 21 with 16, and here coefficient is 1 and remainder is 5. So write the remainder here and coefficient is here, and add this coefficient to the next level. So next value is 6 plus 1 is 7 and plus 4 equal to 11. So it is equivalent of 15. Like that we have to add the values. And this is the representation of positive and negative values. They are called signed binary numbers. Minus and a plus. Here we are putting the sign. In the sign numbers, the MS bit is always indicates the positive or negative. If it is 0, positive. If it is 1, indicates negative. See here, this 1, last MSB is 1, means negative value. If the last MSB is 0, it's called positive. Representing sign numbers using sign and magnitude. So in sign and magnitude form, the last bit MSB always indicates sign bit, as we have seen in the previous example, and the remaining bits are for magnitude of the data. So this is 2's complement. So in this 2's complement, First, convert the binary representation of 5 or any value into its binary value 0, 1, 0, 1, and then find ones complement of 5 1, 0, 1, 0, because ones complement means 0 becomes 1 and 1 becomes 0. So in the 2's complement of 5, add plus 1 to the ones complement, it becomes 2's complement. So this is an example of how to subtract the using 2's complement. Find the subtrahend negative value in terms of 2's complement because mainly this uh, signed values will be useful for subtraction of the numbers only. That's why here, when you are subtracting 2 and minus 3, we can write 2 plus of minus 3. So to find the minus 3, find its complement or one's complement of 2's complement. Here we are finding 2's complement and add those two values. Now check whether it is minus 1 or not. Simply take 2's complement of 1 and keep negative sign as it is. So here it is minus 1 because 2's complement equal to 0, 0, 0 plus 1 is equal to 0, 0, 0, 1 and it is 1 and perform minus in 2's complement. If the result is not equal to the required value, find its 2's complement again and show the negative symbol. So this is one more example of 2's complement and this is a representation of 1's complement and 2's complement sign and magnitude with different representations. So this is even and odd parity table. Suppose here even parity. How to what is meant by even parity? The number of ones must be even. So in this example, we have only one single one. So add one. So then two ones becomes two ones. It's called as even parity. The next example, we are having 1, 2, 3, 4, 5, 6 ones. That's why it will become 0. Like that, the even parity and odd parity will be defined. So these are some of the points of introduction to microprocessors and microcontrollers. So once we keep these all these above explanation, then only we can understand the next topics. Otherwise, it is becoming very difficult. So if you have any doubts, you can ask me.